Okay, so this is lesson 1 of the scale factors and similarity unit. We're looking at SI measurements today, learning how to convert between them and estimate them. A really good lesson for just like life skills. We're going to start with estimation, and to estimate we want to use something called a referent. Really important idea. So a referent is just something familiar that you do know the length of, that you can use to help you like estimate other lengths that you don't know. So something familiar that can help you estimate. So my favorite example to use is in soccer. I play soccer, so oftentimes you'll watch the referee when you take a free kick. They have to measure out 10 meters, and then the other players can't stand closer than 10 meters between you and the ball. And what they'll do is they'll often take 10 large steps, because 10 large steps, each step would be about 1 meter, and so that's how they measure the 10 meters. So it's a really cool way to, or a really easy way to estimate. Here are some other really common ones. 1 millimeter is really, really small. It's about the thickness of a fingernail. 1 centimeter is about the width of your pinky finger, depending on your pinky fingers, the average pinky finger anyways. 1 foot is, the name of it is 1 foot in imperial units, but it's about 30 centimeters. 1 meter, like I mentioned before, is 1 large step. And 1 kilometer, you can think of that like, you might be able to walk that in about 10 to 15 minutes if you're walking at like a normal speed. That's kind of a good, or you can think of it like if you know a track, it's about 4 times around 2.5 times around a track. Okay. You could do this one on your own. The answers are going to vary because it depends on your specific situation. But if we were going to estimate, thickness of your phone, it's probably around 1 centimeter, but it depends on your phone. Height of your seat depends on your seat, but maybe it's something like 60 centimeters, 2 feet, maybe it's 3 feet. Width of a textbook, that could be maybe 30 centimeters, maybe the length of your foot, I don't know. Depends on your textbook, right? So you can do that on your own if you like. Common SI units of length. So these are standard units of length that we typically see in your everyday life. So let's go through them. The base unit here is meter, and then everything is based off of that. So let's get larger first. If you want to get larger than a meter, you would use kilometer, and there are 1,000. Kilo means 1,000, and there's 0.01 kilometers in a meter. So there's 1,000 meters in a kilometer. If you want to get smaller than a meter, we go to centimeters typically first. There's 100 centimeters in 1 meter. And then millimeters, there's 1,000 millimeters in 1 meter. And then micrometer, which is really small. You'd use this more in science. When you're looking at like in the microscope, there's 1 million micrometers in 1 meter. And the symbols that we use kind of match the name. So, but with micro, we use the symbol mu. It's a Greek letter. So that might be new to you. For millimeter, since it starts with M, we use M. For centimeter, since it starts with C, we use C. And for kilometer, since it starts with K, we use K. And then just meter is just M. Okay. And anytime you see these prefixes, micro, milli, centi, kilo, they are going to mean the exact same thing. So if you're talking about like other units, like units for weight, like grams would be the base unit, then kilograms would mean the equivalent thing to kilometers, or milligrams would mean would have the same meaning as millimeters. Okay, this little sentence here is important, so let's read it. You can use any of these units when you're measuring lengths, but it's best if you choose a unit where the length is easy to visualize or understand. So like let's say it's 5.5 kilometers to the park. That's much better to say than it's 50 550,000 centimeters to the park. It's really hard for our brains to understand 550,000. Much easier for us to visualize 5.5 kilometers. So this would be, you know, a far better or more useful thing to say rather than this. Okay. Let's practice converting back and forth between these units. And I find this little chart is a really nice visual. So I'm going to use the same colors I used. So the base unit, I used yellow, and then I used, okay, so my base unit is here. And then I used pink for kilometers. So if I want to get to kilometers, I'm going to multiply by, because there's 1,000 meters in a kilometer, I'm going to multiply by 10 3 times, or by 1,000. Centimeters, I'd go backwards by 2. And then millimeters, I'd divide by another 10. So it kind of shows like how everything is related to each other. Okay. So let's go, let's look at this example here. The length of an ant is 0.003 meters. That is really hard to visualize what that means. I mean, ants are really tiny, so probably a better unit for this ant is going to be millimeters. So I'm going to change it into millimeters. And if we look at millimeters, millimeters are, there's 1,000 millimeters in a meter. So here's how we do the calculation. 0.03 meters, and there's 1,000 millimeters in 1 meter. And what you want to do is you want to set it up so that whatever we're changing to is in the numerator there, and whatever we're going from is canceled out like this. So we're leaving meters and we're going to millimeters. And that's going to move the decimal place over 3 times, and we're going to end up with 3 millimeters. That's much easier to visualize. The length of the ant is 3 millimeters rather than 0.03 meters. Okay, the length of a pencil is 0.07 meters long. Pencils should be measured probably in centimeters. So let's change it to centimeters. So we're going to do 0.07 meters times 100 centimeters in 1 meter. Notice how the thing I'm changing from gets canceled out because it's in the numerator and denominator, and the unit I'm changing to is in the numerator. So multiplying by 100 is going to move the decimal over twice, and I'm going to end up with 7. That's much more reasonable to say. I mean, they're both correct. The pencil is 0.07 meters long, but it's much better to say it's 7 centimeters long. Okay, the hike is 750,000 centimeters long. That sounds ridiculous, right? Probably for hiking, we're going to be talking in kilometers. So let's change to kilometers here. And if I want to figure out what I need to multiply by, so I'm going to start with 75, 1, 2, 3, 4 centimeters. And I'm going to change to kilometers, but I don't know how many centimeters are in a kilometer. This is a really good time to go back up to this little diagram here. And if I want to go from centimeters to kilometers, I can just count the number of steps. 1, 2, 3, 4, 5. So there's going to be 1, 2, 3, 4, 5. So 100,000 centimeters in 1 kilometer. The thing we're changing from gets canceled out. The thing we're changing to is in the numerator. So this time we're dividing. It's going to move that decimal over 5 spots, and we're going to end up with 7.5. Okay, the circumference of a soccer ball is 0.00065 kilometers. That sounds ridiculous. We're going to change it into centimeters. So 0.00065 kilometers times, so this time it's the opposite of what we did in the previous question. There's 100,000 centimeters in 1 kilometer. That's going to move the decimal over 5 times. 1, 2, 3, 4, 5. The circumference of the soccer ball is 65 centimeters. Okay, last few you could try yourself if you want. The distance around a soccer field is, what is that? It's like 400 million micrometers. That sounds ridiculous. Let's change that into meters. Okay, so you could also do kilometers here, but we're going to do meters. So 400 million. I think it's 400 million. Let's double check. Yeah. And so that's micrometers. And there is 1 million micrometers, if you recall, if you look back up at the scale there, in 1 meter. Right? The thing we want to change from gets canceled out, and the thing we want to change to remains in the numerator. So that's going to give us 400 meters. The distance around a soccer field is 400 meters. That makes sense. Okay. The radius of a blood cell is 0.00078 centimeters. That doesn't make sense. That's really hard to visualize. We're going to change that into micrometers. So here's where you would actually use micrometers in real life, probably when you're measuring something really, really tiny. So if we go back up to our chart here, we can see how many micrometers are in a centimeter. Centimeters are 1, 2, 3, 4 spots away from micrometers. So there's 10,000 micrometers in a centimeter. So let's write this out. 0.00078 centimeters times. So we're going to put centimeters on the bottom, micrometers on the top. That's because we always want to cancel out the unit we're going from and put the unit we're going to in the numerator. And there are 10,000 micrometers in 1 centimeter. And so we are going to move the decimal place over 4 spots to make 7.8. So it'd be 7.8 micrometers. So the radius of a blood cell is about 7.8 micrometers. That makes a lot more sense. Okay, the height of a building is 0.32 kilometers. 0.032 kilometers. We probably would never measure the height of a building in kilometers unless it was like maybe one of the tallest buildings in the world or something. Probably it's more reasonable to change to meters. So we're going to go from 0.032 kilometers. We're going to put kilometers on the top, meters on the bottom, because we want to cancel out the type of unit we're going from and keep the unit we're going to in the numerator. And there's 1,000 meters in every kilometer. So we'll multiply this by 1,000 and we'll get 32. So 32 meters. All right, so that's how to change between units, and that is the end of the lesson.